In this example, we have a bicycle race where during the last 50 meters of the race, a cyclist accelerates at a rate of 1.56 meters per second squared. Their initial velocity was 9 meters per second, and we want to find the final velocity of the bicyclist when he finishes the race at the end of that 50 meters. As part of the solution for this, the first thing that we need to look at is the fact that our acceleration here is 1.56 meters per second squared. This is a constant acceleration. So knowing that my acceleration is equal to 1.56 meters per second squared and it's constant, that means I can use one of my three constant acceleration equations. Let's write those down just as a reference so that we can look at those equations and decide which one we want to use. Okay, with our equations written down, now we can take a look at them and see which one would be the most applicable. This equation and this equation both require time to be able to solve it. And we don't have anything in the given statement that says anything about time. So those two equations may not be the best ones to use. So maybe we should take a look at this one. Start with that and see if we can get to the answer using that equation. If we plug in what we know, our final velocity squared is equal to, well, we know our initial velocity. Our initial velocity is 9 meters per second. So we can plug that in here. 9 meters per second squared plus 2 times, and we have our acceleration, 1.56 meters per second squared, times our S final minus S naught. Well, we don't know what S final is, and we don't know what S naught is. But we do know that the change between these two is 50 meters because we're looking at the last 50 meters of the race. So we can consider this part of the equation as a delta S, or a change in position. With that in mind, we put into our equation 50 meters. Now our only unknown is our final velocity squared. So our final velocity is equal to plus or minus the square root of 81 plus 156, which equals 15.4 meters per second. And it would be plus or minus 15.4 meters per second since we have the square on the term here. But since we know that he is accelerating in the positive direction, we are going to just assume that his velocity is also still moving forward, that he's not bicycling backwards. So we can say that we're at 15.4 meters per second. And that is my final velocity and my final answer to this problem.